Here we are studying 6.5, 6.8, version B, test. Now this probably is going to get a little long because some of these problems are long, which you already know that. The first one, I see an x on both sides. The square root is already by itself, so I'm going to square both sides. Remember, when you square both sides, you actually have to FOIL the right-hand side. So on the left, that square root and the squared cancel each other out, so I have x minus 3 is equal to, I have my first, outside, inside, last. Now I'm going to move over my x and my 3 and combine all of my terms together. So all of these can be combined, and these two can be combined. So I have 0 is equal to x squared minus 11x plus 28. Now I'm looking for two numbers that multiply to get to 28 and add together to get negative 11, which would be 0 is equal to x minus 7, x minus 4. You solve for x, so x would be equal to 7 or 4. You must check your work. Repeat, you must check your work. I'm going to check this. So first, x equals 7. I always go back to my original. So I have square root of 7 minus 3 is equal to 7 minus 5. And I get 2 equals 2, so that's true. Yay! And then I have the square root of 4 minus 3 equals to 4 minus 5. I get 1 is equal to negative 1. That's not true. Sad face. So my only answer is the 7. Only answer. Next. So for this, you want to get the root by itself or the fraction exponent by itself. You can solve this with the fraction exponent or using your root. So I'm going to subtract over the 1, and as I do that, I'm also going to rewrite this. This is the cubic root of 2x. Both the 2 and the x are underneath the root because this is in parentheses. It's equal to 4. Divide by 2, so this is the cubic root of 2x is equal to 2. To undo a cubic root, you have to cube it. 2x would be equal to 8. Divide by 2. X is equal to 4. I only have one answer here. Two ways you can look at this is when you do this part right here, this is odd. There's one answer. And also when you cube something, there's only going to be one answer because you can have a positive and negative with an odd. Next. So this next one I'm going to add over my 3 first. So I have 3 square root of 2x is equal to 12. Divide by 3. Square root of 2x is equal to 4. Undo the square root. Make sure you square it. 2x is equal to 16. Divide by 2. X is equal to 8. Feeling great with number 8. Again, here's another long one. You want to get the large root by itself first, so I have to move this over. So I have the square root of x subtract 2 is equal to the square root of x minus 8. You want to get rid of that square root, so this whole thing is squared and this whole thing is squared. You have to FOIL this. So multiply by itself. This is usually the mistake people make a lot. These two cancel each other out. You with just x minus 8. So you have your first square root x times square root x is square root x squared, which is just x. My outside, negative 2 square root x minus 2 square root x, and negative 2 times negative 2 is a positive 4. I'm going to move everything over to the other side. I want to try to get these roots by themselves now. Again, this is a subtract. So subtract my x, subtract my 4, and I get negative 4, these two combined together. Square root x is equal to negative 12. And now, at this point, since I only have the one x, this x canceled, I can solve. I do not have to square twice. So I'm going to divide by negative 4, divide by negative 4, square root x is equal, sorry, that's a negative 4, be 3, square both sides, x is equal to 9. 2 x's. So both of them, this is a little bit easier one because the roots are already by themselves, so on both sides these two cancel and these two cancel. So really I'm just dealing with 3x is equal to x plus 6. Subtract my x, 2x is equal to 6, divide by 2, x is equal to 3. And then you should check this, and this is only one that's there, so that does check out. I want to get my fraction exponent by itself. So 5x minus 4, you can erase that to 1/2, or you can have that as a square root, is equal to x. Square both sides. This is a little bit easier because I don't have to FOIL because there's only one x there. So 5x minus 4 is equal to x squared. I personally always like to have my x squared as a positive. So 0 is equal to x squared minus 5x plus 4, moving everything over. Two numbers that multiply to get positive 4, add to get negative 5, would be negative 4 and negative 1. So x is equal to positive 4 and positive 1. And you must check your work here because there was two x's. So if I check my work, check your work. So the square root of 5 times 4 minus 4 minus 4 on the outside is equal to 0. So this becomes 20 minus 4 is 16 squared root of that would be 4 minus 4. That does equal 0 to 0. So that does work. 4 works. Next, 5 times 1 minus 4 minus 1 equals 0. That's the square root of 1. Square root of 1 is 1. 1 minus 1 is 0. So that one also works. So both answers work here. Bing, bada, boom. You might have noticed, maybe you didn't notice, that these are the exact two equations that were on your practice test 8. So I'm actually going to change these two equations, but keep the actual functions. So we're going to say the function of f is going to be x plus 4. And we're going to say this function of g is going to be x squared minus 5x. Only because I don't want to give you the exact same practice problems. So this first one says 2 times the function of g. So 2 times my function of g. My function of g here is x squared minus 5x because I just changed it. And then adding my function of f, x plus 4. I don't have to do anything with adding because adding is the same as normal. Unlike subtraction, it's the opposite. So this becomes 10x. And now I can combine my like terms. So I have my 2x squared plus 11x plus 4. And my domain here, my domain would be all real numbers. There's no restriction on x squared. Multiplying, I can do FOIL. So x plus 4. You could also do your box method if you wanted to. It doesn't matter either way you choose. I have my first, so this gives me x cubed outside, negative 5x squared inside, plus 4x squared, and my last, negative 20x. These two are like terms. I have x cubed minus 1x squared minus 20x, and my domain is all real numbers. For this next one, you might look and see how this is actually dealing with the inverse of the function. So before I can do anything, I have to find the inverse of the function. So I'm going to write this down because that's what I'm finding here. So I'm going to focus back at this, my function of g, and I'm going to rewrite that problem as x is equal to 3 times y plus 2, and add or subtract the 2 over 3y, divide by 3. So then my inverse function of g is equal to x minus 2 over 3. That's my inverse function of g. So this first problem is saying first plug 2 into your inverse right here, and then use that number to plug it into your function of h. So here's my inverse. I'm going to first plug 2 into that equation. So 2 minus 2 over 3, which becomes 0 over 3, which is just 0. And now it's saying plug into your function of h. My function of h is this right here. So I have 0 minus 2 over 3, which is negative 2/3. That's my final answer for that one. Next one, saying plug the function of g into the function of h. So the ways you do this is just plugging function of g into the function of h. Open circle, this composition. If I write out my function of g and my function of h, it's saying, oops, this is a minus. This whole thing, because that's my function of g composition, is going into just my function of h. So instead of writing x there, I'm going to write my 3x plus 2, so that's this part, minus 2 over 3. Now I simplify. I simplify the top. These two cancel each other out. And I have 3x over 3, which is just equal to x. If you didn't notice right from the beginning, when we found the inverse function of g, that was the same thing of function of h. So these two are actually inverses. And remember, when you plug something into the inverse and then the original, it should end up being the original thing you plugged in. Word problems. So there's two things here. If you want to read that whole thing, you go right ahead. This I'm going to label as my function of f, and this I'm going to label as my function of g. So if I have a 5% discount, that means f of x would be equal to 0.95x, because 5% discount means you're paying 95% of the product. If I have a $200 coupon rebate, that means here's my original and I'm taking $200 off of it. It's asking to actually use and find the composition of functions. The first one is saying find goth. If you were to take the 5% off first and then the coupon, so this is saying the function of f inside the function of g. So the function of f inside the function of g here. So that would be equal to 0.95x minus 200. I don't have to simplify anything for that. Second one is saying if you use the coupon first. So now this is my whole function of g, so that x minus 200, that goes in place of just my x, just this x right here. So in this case it would be 0.95, and then you're replacing the whole box. This one you're going to have to simplify. So it would be 0.95x minus 190. And if we compare these two, this and this one will always give you a cheaper deal. So if you use the discount first and then the coupon, it will always give you a cheaper deal. Question 12. Find the inverse of the function and then state if it is a function. So first, this is the same thing as y is equal to x squared minus 5, because that's just your output. So I can switch my x and my y. You only do this for input, not for real life situations. Add my 5 is equal to y squared. Take the square root. When you take the square root, remember you have to have that plus or minus. And because of that plus or minus right there, no, it's not going to be a function. Because if you were to graph this, it would look like this. And if you do your vertical line test, it goes through more than 1 point. Sorry, that's not a function. Next one, same thing. This is my y value. So I can have my x is equal to y minus 2 cubed minus 1. So add over the 1 first. How to get rid of something cube is the cubic root. And then you have the minus 2, so you still have to add that over. So my cubic root of x plus 1 plus 2 on the outside is equal to y. Is this a function? Yes, because we actually are just graphing these, and that would look something like this. And then I would not have two lines that cross. Last one, not the last one, kidding. So it gives you a whole bunch of stuff. It's asking to find the inverse. Remember, in real life situations, you do not switch the variables. The variables in real life situations do not switch. What you have to do is just solve for the other variable. So first thing I'm going to do is subtract my 3, 0.5w. Now when I'm doing this, 0.5 I would have to divide by 0.5. That's the same thing as multiplying by 2. Because if you look, 0.5 is the same thing as dividing by 2, because that would be like a 1/2. So I multiply both sides by 2. I don't want you to have divide by 0.5. That's not good. So I have 2L minus 6 would be equal to W. That's your inverse model. It's asking if you have a total length of 5.5, so your length is 5.5 minus 6. You should get 5 pounds. You should always make sure you have your labels. You can always go back up to the original to figure out what they're talking about. And last two, so this is a square root. So I can take, I have a negative, I can factor out a 49 from both of these. That would leave me with x plus 4. And when you factor out that, you can separate multiplication. The square root of 49 would be, I still have that negative out in front, negative 7, square root x plus 4. And the next one, same type of thing. I can factor out, they both have a 343 in common, leaving with x, that's a parenthesis, x plus 3. I still have this on the outside of the root. So I can split up that cubic root 343 with the cubic root x plus 3. I still have that minus 5. Cubic root of 343 is also 7. So I have 7 cubic root of x plus 3. Subtract 5 on the outside. Last one, first thing that I'm looking at is they have a square root. So that means when I find my point, it's going to be at the top because I can't take the root of a negative. This is going to move it left 5. This is going to move it down 4. So in my table, I moved left 5, down 1. I said 4, I meant to say 1. Other numbers I can pick would be negative 4 and 0, negative 1, 1, 4, 2. You can also get this from your table on your graphing calculator if you want to. These 4 numbers, the reason I picked these is because this gives me the perfect squares. Plot your points. I should see a curve. I should see a curve with your line. My domain, this is where the graph starts and it's moving on to the right forever. So this value for my x would be negative 5. It's moving on to the right forever. That means it's greater than. My range, here's where it starts and then it's moving up. It's moving up forever. So my value for my y value would be at negative 1. And that's also moving up, so it's greater than. This negative will flip it. This 2 will stretch it. This will move it to the negative 1. So when I rate my table, I notice that's a square root again. So this is where I start with negative 1, and I do not move up or down at all, so that's be 0. If I plug 0 in, that will give me a perfect square. If I plug 3 in, it would give me a perfect square of 4. And if I plug 8 in, that would give me a perfect square of 9. So again, you can use your graphing calculator to figure out this table if you so wish to. Plot your points. I missed my last point, but you get the idea. So here's where I start. My domain is moving to the right because I'm getting larger. That would be x is greater than or equal to my value there for my x value is negative 1. Here, my point, and I'm moving down. I'm getting smaller, so y is less than or equal to my y value there is 0. Again, if you didn't notice, that's always your point right here. This is the point from any transformations that we use for our domain and range. Here my transformation is going to be a stretch. Left 1, down 2. I also know that this is cubic. If this is a cubic, my point should be in the middle. Left 1, down 2. Why is it in the middle? Because of the fact that I can take the cubic root of a negative number. Negative 2 would give me a perfect cube. 0 would give me a perfect cube if I plug this in. Negative 9 would give me a perfect cube. And 7, because my cubes I'm looking for are 0, 1, and 8. And if I plug those in, I get negative 6, negative 4, 0, 2. Plot those points. And this is what you should have. Make sure you have arrows. And then there should be a curve. There should be a curve right here through the point. This is the point where it kind of curves up and then curves down. So when I look at my domain, I go on forever on the left, and I go on forever on the right. So I'm going left and right, so that means it's all real numbers. For my range, I'm going down forever, and I'm going up forever. So that's also all real numbers. And my last one, this will flip it. This will move it down 1. I need both positive and negative numbers because it's a cube. So my table, in the middle, I do not move left or right at all, so that's a 0. I moved left 1. So my perfect cubes would be negative 1, negative 8, and 1 and 8. So if I plug those into that equation, these would be my outputs. Plot those points. Now if you also looked at this graph, it looks different than the last one we just did because this one's flipped. So that's why they look different. But my domain, I'm still going on forever on the left. I'm going on forever on the right. My range, still going down forever on the right. or down forever and up forever. So both of these are still all real numbers. There you have it. That's practice test B. Can't wait to grade your tests, to get some A's in this grading. You have a great, grand, wonderful day. And thanks for showing up.